Hello friends, myself Rajendra Mahajan presenting my video on binomial distribution. Let us solve the problem. Out of 1000 families with 3 children each, how many families would be expected to have? First, no boy. Second, 2 boys and 1 girl. Third, at least 1 boy. And fourth, at most 2 boys. And therefore, to obtain this solution, we consider P as the probability having a boy 1 by 2, means either we have boy or girl, and therefore Q as 1 minus P 1 minus 1 by 2 as 1 by 2. It is the probability of not happening the event, means having a girl. Then binomial distribution formula is P of R is equal to NCR P raised to R Q raised to N minus R. The given information is 1000 families. Out of 1000 families, we have to obtain all these probabilities. Therefore, we consider that quantity as capital N. Capital N as 1000. How many families with no boy? Means R is equal to 0. We try to obtain P of R is equal to 0 as NCR. Small n is 3 here, and therefore 3C R0 P raised to R 1 by 2 raised to 0 and Q 1 by 2 raised to 3 minus 0, we get 3. And therefore, performing the calculation by calculator, we get the value of 3C0 as 1, 1 by 2 raised to 0, n number raised to 0 is again 1, and 1 by 2 raised to 3 is 1 by 8, and therefore value is 1 by 8. This is the probability of no boy, and therefore number of families with no boy is, we have to multiply by 1000 to this probability. Therefore 1000 into 1 by 8, we get that value as 125. This number of families with no boy out of that 3 children. Answer for the first. Then we go for second, 2 boys and 1 girl. Means we consider P of R is equal to 2. NCR, N is 3, C, R is 2, P is 1 by 2, raised to R, R is 2, Q is 1 by 2, and raised to N minus R, 3 minus 2, we get 1. And then again, performing the calculation by calculator, we get the value of 3C2 is 3, 1 by 2 raised to 2 is 1 by 4, and 1 by 2 raised to 1 is 1 by 2, and therefore we have 3 divided by 8 is the required probability. Number of families, 2 boys, 1 girl is equal to 1000 multiplied by that probability 3 by 8, and therefore it is coming as 375. Therefore the number of families with 2 boys and 1 girl each is 375 out of that 1000 families. Answer for the second. Then we go for third, at least 1 boy. Probability R is equal to at least 1 boy. Nothing but we have to start from 1 and up to last number 3. Therefore, P of 1 plus P of 2 plus P of 3. And as per the property of probability, it is nothing but 1 minus P of 0. Sum of all the probabilities is 1, and therefore sum of these 3 term, P of 1 plus P of 2 plus P of 3 is 1 minus P of 0, and therefore 1 minus P of 0 already we have obtained as 1 by 8. Therefore 1 minus 1 by 8, 8 minus 1 by 8, that is 7 by 8. This is the probability for at least one boy, and therefore number of families 1000 into that 7 by 8, we get that as 7000 divided by 8, and therefore quantity is 875. Therefore, there are 875 families with at least one boy each. Answer for the third. Lastly, we find P of at most 2 boys. At most means maximum. Therefore, this is nothing but P of 0 plus P of 1 plus P of 2 means at most or at the most 2 boys, and therefore we try to find out the values of P of 0, which we have already calculated as 1 by 8. P of 1 we have to obtain as NCR, N is 3, C, R is 1, P is 1 by 2 raised to R, 1, Q is 1 by 2 raised to N minus R, 3 minus 1, we get 2. And therefore simplifying it, we get that value as 3C1 is 3, and this is 1 by 2 raised to 3 means 1 by 8, and therefore we get that value as 3 by 8. 2, for which already we have obtained the value. P of 2 is 3 by 8. P of at most 2 boys is sum of all this P of 0 plus P of 1 plus P of 2. P of 0 is 1 by 8, P of 1 is 3 by 8, and P of 2 is also 3 by 8, 7 by 8. Number of families with at most 2 boys as 1000 into 7 by 8, and value is 875. This is the answer for the last. Like this, we can use a binomial distribution to obtain this number of families for different conditions or given condition. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel, and to receive the notification, please press the bell icon. Thank you. Thanks for watching.